Let's start the session. In the meanwhile, I'll introduce people will be joining. So it will take another 2-3 minutes otherwise also. Should I start, Ashish sir, Mittal sir?
That is all.
Can you hear me?
Yes, Indrani, you can start, please.
So we will start with the Azure Code of Ethics. In this and all other Azure meetings, we will act with honesty, fairness, courtesy, competence, inclusiveness, and respect for others, which exemplify our core values of excellence, commitment, integrity, collaboration, volunteerism, and diversity, and shall avoid all real or perceived conflicts of interest. With this, I'll start our webinar session. Good evening, everyone and all. Our topic is role of people, technology, and sustainability in shaping MEP for low carbon solutions. So before starting, we should know about the Azure and the speaker we are going to hear. About Azure, Azure founded in 1894 is a global society advancing human well-being through sustainable technology for the built environment. The society and its members focus on building systems, energy efficiency, indoor air quality, refrigeration, and sustainability within the industry. Through research, standards writing, publishing, and continuing education, Azure shapes tomorrow's built environment today. Azure India chapter founded in 1990 by Dr. P.C. Jain. You can visit our website, www.azureindia.org. To join Azure, you can call Secretariat staff. Me and Ranjit are there always to help and guide in membership and queries also. So we'll start with our eminent speaker, Mr. Ashish Rakheja. Mr. Ashish, though all the speakers are renowned and they don't need any introduction, but still as a matter of format, I'll take the privilege to introduce. So Mr. Ashish Rakheja is a past president of Azure India chapter, and currently he is Azure US Vice President. So it's a proud moment for all AIC and Azure India chapter, as well as internationally. It's a proud moment that he is representing us. Thank you, sir. So Mr. Ashish Rakheja is partner at AU and Consultants and had a postgraduate degree in thermal engineering from IIT Delhi with over 28 years of work experience. Mr. Rakheja has won many awards and delivered over 1,000 talks on various facets of building design across the world. He is an active member of over 20 technical societies and regularly contributes his time on writing standards, codes, and position papers for government bodies and technical societies. He is involved in imparting training to building architects in the field of building services and visiting faculty at leading schools in India. He is spreading the green building movement in India in capacity of role as chairman, Technical Committee of Indian Green Building Council, IGBC. Mr. Rakheja is also Vice President, as I mentioned earlier also. So over to you, Ashish sir.
Thank you, Indrani. Thank you so much. If you allow me to share this screen. Indrani, you can hear me?
Indrani, please unshare your screen so that Mr. Rakheja can share his screen.
Please go ahead, sir.
Thank you. Namaskar, everyone, and thank you, Indrani, for the introduction. Since we have a lot of speakers, I'm just going to set the tone for the conference. I'll take about 15 minutes. The topic today is very interesting. It talks about the role of people, technology, and sustainability in shaping the MEP industry. Now, one thing that we are all aware that is it's something that people are now been talking about in a big way, and the topic is very the people, technology, and sustainability contribute. Before going there, I think we also need to see what has the last 20 years of green building movement been all about. As you are aware that we started a green building movement in India in 2001, and it's been in 2 decades. 2 decades, we have more than 10 billion square feet of green that we have currently. India currently is regarded as the second largest green footprint in the world. We have done a lot. We have arrived in a big way. We have prevalent rating systems today in India. 3 of them quite popular, which is there on the screen for you. And interestingly, all of them have the same structure. They all talk about the same areas where they concentrate on. But if you look at the rating systems, they've all pushed for the similar things like passive design, active design. Today, the things like building form, orientation, shading of the envelope, the chhajjas, daylight integration has become something that we're all familiar with. In fact, in a lot of places, it's gone into mainstream in terms of as part of the curriculum at the colleges too, especially at the architecture colleges. If you look at all these rating systems give you a rating based on the design. So far, the 2 decades have been all about design, has all been about equipment performance. If you look at even the other standards that we refer to, or the codes that we refer to, ECBC or Azure 90.1 or the IGBC rating systems, or any of the rating systems that I was talking about, once again, the prime focus is on design and on the equipment efficiency. So this is what the 2 decades of green movement has taught us. Its impact has been significant on our industry. If you look at the focus today is on equipment efficiency. Everybody goes and says, efficiency kya hai? And I'm sure I'll not be out of place if I talk about the famous ad, ki mileage kya deta hai? Similarly, every time we are selecting equipment, we are talking about efficiency kya deta hai. Energy efficiency is talk about it. Water efficiency is something that we always refer to. India today is home to world-class products, be it American markets, American products, be it European products, or products coming from other parts of the world. The certification is something that is moved in. The codes and the standards that we refer to, we want our equipment to be third-party certified so that we are guaranteed of its performance. Interestingly, as I said earlier, all that is about equipment, all that is about design. This is where the industry is now changing. If you look at where we are going is performance-based. I'd like to emphasize my point by talking about the labeling programs which are there. I have a labeling program called BEQ. Similarly, in Europe also the labeling programs for buildings are there. India has its own, which is called the star labeling for the buildings. And many of you not even have heard about it. The reason being, nobody talked about the labeling so far. The labeling was limited to equipment. Again, 5-star labeled. Window air conditioners, geysers, refrigerators is something that we're familiar with. But when we say talk about buildings, possibly no. The reason was nobody talked on performance. And incidentally, the star labeling for building has been around for nearly a decade. Even ISHRE today is now focusing on building performance standards. There is a ISHRE India Building Energy Performance Standard that is coming up, which talks about the performance of each of the subsystems that we typically have in a building. Subsystems would be air conditioning, plumbing, electrical, envelope, lighting, and it goes on like this. So it looks at the building energy performance, which is about actual performance. I'm going to give you a real life example of a project that we've been recently asked. As part of the brief of the project, this is what came to us, a project sustainability vision, which talked about the 14 points on which the MEP needs to concentrate on, right from climate control to carbon to quality of life to waste to water to energy to air. You need to focus on everything when you're designing. And it is not about designing alone, one needs to achieve it. We have been provided performance goal for each of those 14 points. Let's say it talks about outdoor thermal comfort. That means not only people need to be comfortable inside the building, they need to be comfortable outside the building. Facade has to achieve a certain performance. Energy has to receive a certain number. So there is a quantifiable number given to us for every element of the 14 that are there. And that means it is not about design, it is about achieving the performance for all 14 elements. The whole game changer now is the COP26, which happened, where 140 countries have now pledged to what we say carbon neutrality. India too has not been behind. We have set targets by Honorable Prime Minister, where we said that by 2070 we'll be carbon neutral. But 2070 is far away. A lot of us would argue against that. 2030, which is nearby, we talk about nearly 50% of India's requirement, energy requirements to be met by renewable. Not only that, reduction in the carbon intensity of Indian economy by less than 45%. So these are all quantifiable targets which are in front of us. And none of them come only by design. All of them focus on performance. And that is what I keep harping about. If you look at the carbon, the very targets that are being set to us, typically a building contributes to carbon emissions right at the construction stage, then throughout its operation stage, and then finally at the demolition stage. Construction, when we are doing the construction, when we get the material from the raw material comes to us, it gets transported to site, it gets constructed at site. Whether it's operation, that means throughout the life cycle, maybe of 50 years, what energy it consumes and what are the equivalent carbon emissions. And finally, demolition, where does the waste go? What is the contribution of it towards the carbon emissions being there? And these concepts are bringing in things like cradle to cradle. That means how can the material be reused into the system? And what are the associated carbon emissions? If you see the whole of the thing, where does the design sits? Design sits possibly at the construction stage as a very small element out. Everything is now about actual operation. At the construction stage also, quantify what is that we are using in our design, the materials that we are using in our design, what is the carbon footprint of that? Operation, the building, the equipment that we have selected, the MEP equipment that we are installing, how does it perform? And finally, at the demolition stage, where does it go? So if you see here, the design has a very small component. Of course, design is the basis of it. But at the end of the day, is all about actual performance being achieved. And this is what we have seen as a strategies when we talk about the low carbon, the net zero energies, the net zero water, the net zero waste, the EVs that we are saying, they all become a reality. And very fact that today the trends in sustainability are all about performance. The new rating systems which focus on energy, water, waste, carbon, resiliency are nothing but net zeros. How far we are able to go, push the boundaries to reach what we say near net zero or net zero. Net zero energy, net zero water, net zero waste, net zero carbon, and finally the resiliency also. In all of these areas, there are both Indian and international rating systems available, and more are being adopted. I'll give an example. I was associated with the net zero energy rating system. I had the opportunity to chair it at the IGBC, Indian Green Building Council. We formulated in 2018. Between 2018 and 2020, in 2 years, we had 9 buildings that went for certification. Between 2021 and 22, and 22 is not yet complete. In 21 and 22, there are 70 buildings, 70, which are going for the certification. You can see the spurt. It's all about carbon, is all about net zeros. And net zero is all actual operation based. So when we come back to our topic, when we say, how does the people design? They have to look at the MEP systems that to look at. I think this is where it goes. It all become performance based. I would like to say that net zero buildings are not how we design, but it's a mindset change of how we design, construct, and operate our buildings. We have always focused a lot on design. Design is where we are maybe at 110%. Out of the 100, if I was to give to designing, we are at 110%. But it's a different story when it comes to construction and how we come to operation. We don't even worry about it. But that is not how it is going to be going forward. The designs will become performance-based. And that's where the people, that's where the operators, that's where the suppliers, everybody gets involved. Everybody has to meet the performance. Not only that, things like digital twins. We've had earlier webinars also coming from Capricorn, where we spoke about digital twins. Digital twins become a tool in which you validate the performance of existing buildings and also look at what you can do for the new buildings. Both the digital twin can be done as something which tells you the performance before you physically go and construct or renovate a building. So they have become a key to what we say a high performance building design. Again, the focus so far has been in the design from an MEP has been the air conditioning engineers, they go design on their own, the electrical are doing their own work, and plumbing are doing their own work. Even though we say it's an MEP industry, but there's hardly a relationship between them. That cannot be the case going forward. If you have to reach a performance for a building, let us say you're aiming for a net zeros, whether it's net zero water, whether it's net zero energy, the interrelationships start coming in. Things like in a water energy, we talk about what we say energy water nexus. Terms like these are now being used in the industry. These are the upcoming trends, phenomena, and the interrelationships become the most important thing, because then only you have an optimized performance available. And finally, the technology and execution. You have to get it right the first time. Because if you don't, जो हमारा पहले होता था कि बना दो, तोड़ दो, फिर बना दो, we all come and put the services. अरे फायर फाइटिंग वाले ने पाइप पहले लगा दिया, डक्ट वाले ने बाद में लगाया, अच्छा एक काम करो, खोल दो, फिर लगा दो. All that means higher carbon footprint for the execution that you're doing. It cannot be something which will be accepted going forward. It has to get it right the first time. And that is where you start things like BIM, building information modeling, that comes in. The later speakers are more about it. BIM is just a tool which helps you to coordinate, to get the interrelationships between the systems in a right way. It helps you predict the performance. It helps you to do the construction. It helps you do the maintenance of the building, the operation of the building. So BIM becomes a tool going forward for getting it right the first time. Not only that, India is currently untouched by the concepts of the ARs and the VRs, augmented realities, virtual realities. So far, they're being very little used in what we say the interior designers with the make a presentation to their clients. Going forward, virtual reality, augmented reality is something that will live in. The MEP engineer would be able to see the performance. First, the performance, assess the performance, and not only that, during the execution, these tools are also going to get used more. I'm sure you've heard about modular construction. What is modular construction? Basically, we are saying that constructed off-site, not on-site, but off-site. The reason is you are able to get complex installation done easily, more efficiently, and at a lower carbon footprint. And it has been estimated that modular construction can help up to 90% waste reduction, reduced on-site pollution, and transportation material also is optimized. Similarly, the concepts like 3D printing, again, the intent is to do as much as possible in the factory itself, at the not on-site but off-site. And last but not least, as I said earlier, is about operations. The concepts of IoT, AI, they are going to become a reality. We cannot have any loops in the whole cycle. Everything from design to construction to operation has to be right. And for getting it right, the use of machines, machine learning, artificial intelligence, IoT is something that we're going to rely on. And that's why you see a lot of companies today putting focus in this area. This morning, I was reading an article on the Economic Times. Again, the focus was AI, construction, AI, and machine learning. So you hear these terms more and more, but you're going to see these becoming disruptions going forward in our industry. It is estimated that artificial intelligence alone can reduce the GHG, the greenhouse gases emission, by nearly 5 to 10%. So that is the impact they're going to have in future. So I'll just end this talk. I've taken my 15 minutes that we need to rethink the way we are doing. We need a mindset change to start focusing on not only on design, which the 2 decades of green movement has taught us, but move on to now construction and operation of building to get to involve people, operators, equipment, and design into getting the low carbon solutions. So thank you very much. I'll hand it over back to the organizers now.
Thank you so much, Ashish sir, for sharing your expert advice to the content. And let me tell all the participants that we will take the Q&A session at the last of this webinar so that you can hear them all and come to the conclusion what to be asked and not to miss the chance. So thank you so much, Ashish sir, and he has to leave. Sir, for sparing time, thanks again.
Thank you, Indrani, and I'm sure my colleagues will be able to take all the questions that come up. They are quite, as we said, they are very well known, and they're quite well aware of the topic.
Okay, Mr. Rakheja, before you leave, can we ask all the speakers to share their video once so that we can take a snap? Thank you so much.
Thank you. So I'll
Thank you,
share
everyone.
my screen. Okay. So I'll share again my screen. And our next speaker is Mr. Rakesh Mittal. He is DGM Engineering DLF Limited, DGM Design and
It is
Engineering.
Indrani, sorry, interrupting. It is Ritesh Mittal.
Oh, I'm so sorry, sir. I'm so sorry. My fault. Okay. So I have written below Ritesh Mittal. I don't know how it, anyways, I apologize for this. Mr. Ritesh Mittal is a civil engineer by qualification and a certified PMP professional, having more than 16 years of experience in design, construction, BIM industry. He's having experience of complete spectrum of construction industry, consultancy, client side, as well as site. Successfully implemented BIM 360, ACC build, thorough usage of BIM and Power BI on commercial projects with one of the leading developers in NCR. Over to you, Mr. Mittal. And I request everyone to keep on mute because some disturbances were going on while Mr. Rakheja was speaking. So kindly cooperate. Thanks a lot.
Yeah, thanks a lot, Indrani, for the introduction, and a very warm welcome once again to all the attendees. So today I shall be presenting on how we can achieve sustainable design and construction using BIM technology. Just to give a brief introduction about the types of carbon emission during the life cycle of the building that we come across, although these have been captured in detail by my other fellow presenters, they are embodied carbon, which originate from the manufacturing, transportation, and installation of building materials. And the other one is operational carbon, which originates from a building's energy consumption during operational stage. As far as the construction life cycle of a project is concerned, so generally it consists of 5 major stages, like the planning and design, material and construction, operation, maintenance and renovation, and deconstruction and waste disposal. And each stage has several processes and materials that could play a vital part in emitting CO2. So let's see in a bit detail how these stages impact the CO2 levels individually, and then we shall study how BIM can help us in negating these. So as far as planning and design is concerned, the planning and design phase is of paramount importance for carbon dioxide reduction. The decisions we make during this stage directly affect the operations efficiency. A good design is that which increases the potential for emission reductions over the building life cycle, as well as eliminates the need for expensive carbon dioxide reduction measures during the later stages. Designers must study the interaction between climate conditions, building forms and functions, thermal characteristics, building services, system design, and how occupants influence a building's environmental performance before they propose a design solution. Also, along with an excellent design, the selection of appropriate materials and technology during the planning and design phase can provide an opportunity for carbon dioxide reductions in the industry. The next one is the material in construction. A number of processes result in the emission of greenhouses, such as the extraction and processing of raw materials, production and transportation of construction materials, materials delivered to site and disposal of construction waste to landfill. As the energy and materials used during this phase are mostly non-renewable, the carbon reduction we achieve in this phase can be very substantial. The next one is the operation stage. Several studies focusing on energy consumptions and associated emissions during the operational phase have postulated it accounting for 70 to 80% of the environmental impact throughout the building life cycle. Energy consumption during the operational stage itself is approximately 28%, which is nearly 3/4 of the total emission contributed by the construction industry. We can attribute the amount of energy consumed during this phase to the extensive use of electrical appliances, including heating, cooling, and lighting systems over the entire life cycle of the building operations. The next one is the maintenance and renovation. As the building approaches the later period in its lifespan, the wear and tear results in two options. That is, either we can renovate the building or demolish and reconstruct it. Renovation and maintenance activities involve replacing low-performing systems with newer ones. This process of removing low-performing systems and disposing of them results in significant carbon emissions. The last but not the least is the deconstruction and the waste disposal. The construction industry consumes approximately 40% of the raw materials worldwide. This means that we need to dispose of roughly the same amount of materials when we deconstruct a building. Hence, carbon emission during the deconstruction and waste disposal stage is also quite substantial. So with this, we can understand that every stage is very important. And at every stage, somehow we come across CO2 emission. So now, how we can say that BIM technology can help us in all this. So in order to overcome these factors which cause the increase of CO2 levels during the life cycle of the project, one can adopt BIM and help in sustainable design and construction. Using BIM, data generated during design and build over the whole project lifecycle enables faster, safer, less wasteful construction, and more cost-effective, sustainable operation, maintenance, and eventual decommissioning. Ultimately, when we do a coordination in BIM, then all the BIM inputs provided by all the project partners aid sustainability in many ways. So we get certain design benefits out of the BIM process during the design phase itself, like pooling technical, operational, construction, and manufacturing knowledge enables design to be value engineered and optimized for every stage of the delivery and operation. Design changes made while the project definition is still flexible and can accommodate without cost and time penalties. Whenever one party makes a change, all other disciplines are aware and can adapt their inputs to or find an alternative solutions also. Measurements and comparison of embodied and operational carbon associated with different options is possible. BIM enables automatic clash detection, eliminating the need for ad hoc solutions and saving materials, time, and cost. Coordinating of design, cost, planning, production, and construction contributes to accurate ordering of materials and equipment, eliminating waste and rework. Also, offsite fabrication of common components, which further eliminates over-ordering, reduces wastage, and allows off-cut materials to be reused and recycled. We also get certain benefits as a post-design process also, like improved quality of workmanship and worker safety, better quality and greater durability, fewer deliverables to and less wastage, removal from the site, reducing transportation and associated fuel consumption, carbon emissions, road congestions, and noise pollution. 3D visualization of the final product enables the construction team to understand and plan for the deliverables in a better and most efficient way. With the 3D models, manual quantification work gets reduced drastically, which eliminates leads to lesser variations in work orders and amendments. This also leads to better control on the budget. Now, everyone till now understands that BIM is 3D, but it is not just 3D, it is more than that. So to touch base onto the potential of BIM, it's not just 3D, it's more than that. We can achieve 4D, 5D, 6D and more with it, provided the information is there and is fed in on a timely basis. To give all of you a perspective, I just tried to list down certain relevant features of BIM which help in achieving the same. Like early development of a 3D asset model makes it possible to generate visualizations that all stakeholders can interact with. This makes the designer's intentions absolutely clear, enabling stakeholders to propose design modifications that improve project outcome and prevent the need for modifications after the project has entered service. Detailed element information helps in understanding the element configuration related to level, width, length, dia, pressure, etc. Digital design and visualization also makes it easier to compare alternative options, allowing environmental and visual impacts to be assessed and providing opportunity to discuss the concerns of the public and special interest groups and identify the best solutions. Phasing option information helps in understanding the sequence in which the construction activities shall be executed at site. Quantification can be done for all kind of objects having different measurements like volume of concrete, length of pipe, pressure of ducts, dia of pipes, etc., which helps in understanding the unit of measurement. WBS codes could be linked to various elements of the BIM model, which further helps in understanding the sequence of activities pore-wise. Pore-wise data could be added into the model based on which the pore sequence at various floor levels could be understood or work could be assigned more effectively. Similarly, BOQ codes could be linked to various elements which lead to ease in building processes and save time for quantity checking and bill clearances. Planned dates could be punched in from schedule and later those could be tracked on a daily basis with actual dates, thus providing the comparison between the two and helping in controlling the project with better visibility and control. Construction status could be updated as per the progress at site in the dynamic environment, which is the ultimate requirement of management on everyday basis. With the basic cost entered for individual categories, better control could be achieved on the project budget and cash flows, and forecasting could be done based on the pre-scheduled work sequence entered. BIM also allows full detailed component information to be embedded into the asset model. This can be used to plan maintenance activities for assets with different design life so that major repair and replacement programs can be synchronized, minimizing cost and disruption. In the end, to make the thing simpler, each and every information could be exported to Excel for wider access and usability if required. So this was all about the textual concept. So I just added one video so everyone can just see that how we say 3D, 4D, 5D coming into action. So here you can see that we always see MSP schedule in a textual page. So, but when you see that in a graphical interface, you actually come across various stages that at certain location excavation keeps on going on, and at certain other locations we can have the so at other locations you can have like PCC, at certain other locations concrete is going on, and then eventually waterproofing can start, and then a second phase could be there where you lead to a second phase category of excavation, and then further process could be happening. Like you can understand that isolated footing is also in progress, and over here slab is also in progress. And at the bottom, you can see that we can also track it month-wise, week-wise, day-wise. So similarly, we can have the cost part also added to it, that at a certain duration in time, what is my cost? So it helps overall in looking at the picture overall. So it's not just that I can just build one single building with it. Whatever model you have, information you have, that's why I said that information is very important. Whatever information you will be feeding in, it will be displaying that category. So where you can see now building is getting a shape and it is started above the ground level itself. Then slowly, gradually you'll come across that, okay, fine, I can have a walkthrough also. I can show it to the clients also at the same time. So now you can see that in the second phase also my construction has started and my first phase itself is going on. And then slowly, gradually, my finishing works will also start with the block work and everything. And you can always have a keep on track that, okay, fine, I entered the 13th month now. Now you can see the finishing work has started for this part, and slowly, gradually, it will start moving into this part also. But like this, you can have numerous combinations, whatever you want to see, how you want to see, all those combinations could be generated. You can add coloring also. So it's all about how you want to visualize it. Now you can see that the building is getting shape and facade is coming into picture. This first phase building is almost complete. And now you can see the second part is getting finished with respect to the facading. And similarly, the third part is also getting finished slowly, gradually as we move up. So this can be aligned with respect to various categories. Also, I can have 4 different contractors. I can color code with respect to contractors also to see the progress. I can have a delay analysis also. So this virtual construction actually helps you in facing all the issues. Those will be faced at a later stage by the construction people. So now you can see the road work has started working as per my schedule. Slowly, gradually, I'll see the landscape also coming into picture when the infra is complete. The roof waterproofing is happening as of now. So now the landscape is coming into picture. So here also you can see the bigger landscape chunk is also coming into picture. So this is the complete picture. So now if the construction people will have this model as an access, then definitely they So this was one part with respect to only the scheduling part. So then coming on to the various simulations, when we say 4D, 5D, so we can have different variations also, like subcontract-wise color coding can be there, or we can have the 4D, 5D visualizations coming into play, or we can have the delay analysis coming into play, or we can have the SPA indexes, or the cost indexes also can. Yeah, that's it from my end. Thank you.
Thank you so much, Ritesh ji, for such a wonderful session. And would request you to stay back with us so that we can take the questions at the end of the session, and you can also participate in that in answering.
Sure.
Is this okay with you, sir?
Yeah, sure. Thank
you so much. I'll share my screen again. So our next speaker is Dr. Varun Jan. He is past president and presently he is co-chair CTTC of Azure India chapter. Dr. Varun Jan is the past president of Azure India chapter. He holds a bachelor degree in electrical and electronics engineering. He attended 1-year professional design engineering training in air conditioning at Wisconsin in USA in 1997. He worked for 2 years in California, USA. He obtained his MTech degree from Indian Institute of Technology, Delhi in 2000. After his MTech, he involved himself in research as a PhD student in Center for Energy Studies Department at Indian Institute of Technology, Delhi. He is working as Director Technical in one of the leading building services consultancy firm, Messrs. Sanelec Consultants Private Limited. Also, he is the founder of naukri-a2z.com. He is a certified energy manager cum auditor by BE, Ministry of Power, Government of India. He has been associated with HVAC industry since 1996. He's associated with so many other societies, like American Society of Heating and Refrigerating and Air Conditioning Engineers, Azure, Association of Energy Engineers, AEE, USA, Chartered Institution of Building Services Engineers, London, CBISE, London, Society of Energy Engineers and Managers, SEEM, Indian Society of Heating, Refrigerating and Air Conditioning Engineers, ISHRE, Solar Energy Society of India, SCSI. So we have eminent speakers, all the eminent speakers are with us, so don't leave them without your questions. Start putting your questions in Q&A box. We will take it at the end. So over to you. I'll stop sharing my screen.
Yeah, thanks, Indrani. Can you hear me?
Yes, sir. Yes, sir.
Yeah. Good afternoon, everyone. My presentation will cover the class detection, quantity, and how the quality improvement or quality assurance can be done through BIM. Ashish has given a wonderful presentation indicating that what India is envisaging, what India's vision is by 2030 and 2070. And Ritesh has given a wonderful presentation that if everything is done through BIM, you can even see delays during execution, where delays are happening, how the different subcontractors are executing it and what stage the project is, what are the delays. There is a feedback which can go to the design team that where there were delays, and that can be used to improvise. Now, why BIM? Designers envisage something, they design something, and whatever get executed, there is a vast difference between that. It's not that the execution team is not good. It's because the information which is required to be given by the design team due to the tools available to them is not available due to time, or tools which are available to them, they are not able to give that much of information that the execution goes very smoothly. What is the expectation and reality? Just one slide I added to see that how the design is as envisaged is what is the expected, and what reality is, what we get during after the execution. So what is expected? Good planning and coordination, reduced RFIs, minimizing the risk of changes, costly changes during execution. What is the reality? Improper coordination by design team, human error in design, delay in shop drawing approval due to site coordination, the drawings prepared by the contractor, shop drawings, later on it is seen that there are lots of clashes. There is lots of changes in BOQ, more time spent by design team during execution. Client is asking every week or sometimes couple of times to visit the site to resolve the issues, RFIs which are generated. Now the project management, who are supposed to only schedule and monitor the project, they get involved into design issues and coordination and all these things. So they have to also increase their team. Why BIM adoption in India is very slow. Very few real estate giants have made BIM usage mandatory. Most of the clients are not making BIM mandatory for architect and consultant. Why adoption is slow? Let us just see. Let us go back to that era where in 90s, where we had only manual drafting. Manual drafting, when AutoCAD came in India, I think that was somewhere in late 90s, 96, 97. The manual drafting got eliminated from the market very soon. But BIM tool is available from more than 2 decades, but still AutoCAD is the prominent tool for design team which they use. What are the benefit? It is the fastest 2D drawing tool, and people are not going to leave it easily because BIM tool is little, it takes quite a bit of time to do design on BIM. Class detection is also not possible. That is the major challenge in AutoCAD. Visualization is not possible. You cannot visualize the project. Now, when we come to BIM class detection is possible by any tool of BIM. Usually in India, few tools are used, but internationally there are many tools which are used. Visualization is possible only in by the people who is working on it. But when the drawings goes to site, at that time it becomes again like 2D. So it is difficult for people unless they keep all BIM tools and everything at site, which is expensive. Client is not ready to do that. So visualization. The other challenge is this in BIM is that client is always giving very less time to release the GFCs, tender documents and all. So the client team, the design team has to have two verticals separate. One is who is working on AutoCAD, then who is working on BIM. So they can release as per the site expectation drawings early through AutoCAD and then redraw it in BIM and then deliver it to site. Now, walkthrough is also very important part, which gives more visualization to the site team also. You know, class detection is possible. If you're walking through the site, virtual site, we can easily see the clashes by our own thing. And these are walkthroughs are once done. It is very light, so it can be operated in any of the computers. And once the walkthrough is done, seeing the walkthrough, you do not need any special or costly software. It is freely softwares are available to use that. The only thing is that now the design team has to have a couple of more people, somebody who's working on AutoCAD, somebody who's working on Revit, BIM tool for class detection, somebody is doing walkthroughs in different softwares. So you need to have more team working on it. So yes, to arrive to this stage, it takes quite a bit of time. Client should have patience to give that much of time to the design team for them to deliver this kind of drawings. I will try to show you walkthrough if time permits at the end, one of the walkthrough. Now, what significant changes BIM has brought in MEP industries? Let me just go through a few slides. We all know that there is a coordination benefit through BIM. You know, you can't see these clashes which you see sprinkler pipe is going through the duct at different location. The complete design is so complex. On the left side, which you see is the clashes. On the right side, where you see when the clashes are resolved. So this cannot be done on 2D software. This needs to be a 3D software, a BIM software where you can do that. Eliminate RFI or reduce RFIs. You know, all these. Can I bring this down? I don't know how to do that. Okay, so the PMC get involved in this. If BIM is not used, the PMC get involved. There are so many of errors which is found in design team submissions. So it goes back to them. They again rectify. But in BIM, you can work out that what are the errors. You can get the reporting done through APIs that what are the errors, where the friction drop is going too high, where the warnings are only there, where the errors are there, and then you can rectify them. Shop drawings can be extracted from the 3D BIM model, saving because no clashes are there, no additional cutouts are required. That saves lots of rework and wastage. The big picture is this, that project management team can focus on the scheduling and monitoring rather than working on the revised BOQ, shop drawing corrections and all these things during the execution. Now, how we can optimize, you can do a cooling load calculation through the BIM software. It can analyze all external factors, internal factors, all envelope loads and internal loads, and give you the cooling loads, heating loads during winters and summers, monsoon. Then the other thing is the other challenge, which is not a challenge, I would say. The different people are using different BIM software. So there is a GBXML file. This is a common language which can be transported from one software to another software. If suppose
We have lost you, Mr. Jain.
Yeah, I think he got disconnected.
We'll give Mr. Jain a minute to come back. So, Mr. Ritesh, we have a
The
question
meanwhile,
for you.
yeah.
So meanwhile, maybe we can take that question. So what Mr. Sham Bhosle wants to know is, what will be the cost for BIM software for HVAC industry? How this step-like procedure for you was shown for construction?
Yes, Pratik. So, Mr. Shyam,
Yeah,
so
hi, everyone. Sorry, there was some internet issues. Usually that does not happen in office, but it happened. Can you somebody help me which screen I was when it got disconnected?
You were mentioning that GBXML get exported.
Yeah, okay, wonderful, great. Thanks, Kanak. So GBXML file can be extracted from one BIM software to another BIM software so that you don't have to give the input to each and every software again and again. And the sizing of duct left hand side, what you see is the duct sizing which has been done automatically, the pipe sizing which has been done automatically, circuit diagram that balancing of loads can be done automatically. You can see that similar loads are the DB loads are balanced properly. Creation of sewage and water supply piping through fixture units by auto sizing. There's some limitation in some of the BIM software on drainage piping automatic connection. However, water supply pipings are easily done. You can create different report which can give you an idea about what level it is, name of the space, what is the cooling load, what is the supply CFM, what is the cooling set point temperature, how much outdoor air is added, the equipment, mechanical equipment schedule reporting can be done, how many air washers are there, centrifugal chillers are there, and how the air terminal schedule also you can get. Even if you make any changes, you can directly go back to this, which can give you the revised BOQ quantities. You can do the duct scheduling, and you can see that which supplier system the flow rate is, what is the overall duct size, what is the velocity, what is the friction drop, bottom elevation, what is the length. Similarly, on piping also, you can get all these details. So much of information can be extracted in of report from the BIM model that customize the report as per your requirement. You can do quality control like for ducts. If you see this sheet, it says that different friction drop, higher friction drops are used in different AHUs, and when it is corrected, you can see the constant friction drop is used in respective AHUs. So the report can be generated that what are the errors are there in the design, because human error is unavoidable. That happens. It's only a tool. It does not automatically these are the warning which you see, what are the US GPM in piping, and then it is corrected. A remark can be given and this file can be sent to the execution team. Similarly, for a sprinkler also, this can be done, where the errors are there, where the warnings are there. The report next bottom you see is that everything has been taken care. user experience. You get less time to generate GFC layouts, less time to generate quantities. Even the revisions which are happening, you can generate the quantities. You can even generate estimates through this, and reduction in RFI is definitely there, and saving on construction cost is there because you are doing a complete class detection. These are some of the images of the 3D model. You can see, you can visualize things very easily, that how the crossings are there, what are the levels are there. You can see if there is no cutout, you can visualize through this section, visualize through 3D model that there is some clashing which is happening at some point. The MEP systems are so complex that it is very difficult in a 2D model to rectify each and every clashes which are there. Challenge in BIM is that it's an expensive software. Yes, software and hardware upgradation of year licenses must, which is also costly part. Limited availability of trained designers, architect, consultant. Not all architect and consultant use BIM. In this, when you're using BIM software, you need the entire design team to be on BIM. Availability of ready-to-use BIM libraries from vendors and suppliers. Like in US, same supplier would having lots of libraries which equipment they're providing in US, but in India, same supplier would not be having libraries for Indian equipments. Require little more advancement in electrical system. And the other limitation is the auto dimensioning, which is an issue in 3D model, which is a challenge. So it takes quite a bit of time in a 3D images to do the dimensioning. Then architectural and structural consultant do not provide 3D model. So these are the challenges. If these challenges are overcome, I think the adaptation, which is slow in India, will increase and will be able to reach. I will try to show you, if time is there. Indrani, can I show a small walkthrough?
Sure, sir, please.
You know, once the model is done, it will be easy for anyone to just do the walkthrough. The building is not yet built. It is one of the project in Gurgaon. They have 5 basements. So you can see it is written basement 4 here in this. And it is also showing the grid where you are actually at that particular point. So you can visualize this. You can see light fixtures, drainage of upper basements. Red one is the exhaust duct. Supply duct is coming at the lower level as per the fire norms. You can see sprinkler system. Let me take you to the chiller plant room. As Indrani is saying, there is still some couple of seconds left. It's very easy to navigate. You know, person like me who is not very good with the technology, using cell phone and all to the maximum extent, I am able to navigate this very easily. So once the walkthrough is done, anyone can navigate from the free downloaded software from the internet. You can see pumps are there, chillers are there. So everything at site, this has not yet come. It's a real-time project which is there at site, where the chillers are not installed, but one can visualize each and everything in this. So any project, this walkthrough can be created and people can easily visualize at site. Even the supervisor and all, they can understand where the problem is. There could be a good collaboration between the different contractors, different agencies. In MEP itself, who are working on at site, then they know that what is the reason why the spaces are different spaces are given to different respective services. I think I am done, Indrani. Thanks. Let me unshare it. Sorry about that. In between, some internet issue was there.
Technical issues, no issues at all. Thank you so much, sir, for such a wonderful presentation and walkthrough. We, this way could visit a factory, a company. Thank you so much, sir. And please stay back with us. We'll take the questions at the end of the session.
Sure.
I'll share my screen again. So our next speaker is Mr. Kanagraj Ganeshan. He is our president of Azure India chapter. Mr. Kanagraj Ganeshan is a director integrative design solution. Mr. Kanagraj Ganeshan specializes in the field of building energy efficiency, climate neutral urban development, and sustainable cooling. He is a postgraduate from the Indian Institute of Technology, Madras, a certified measurement and verification professional, CMVP, and a certified master trainer for energy conservation building code, ECBC in India. Currently, he holds president position of American Society of Heating and Refrigeration and Air Conditioning Engineers, India chapter. He is an ardent advocate of integrated design process utilizing state-of-the-art stimulation, software, and digitalization. He has implemented several projects for governments, bilateral agencies, multilateral agencies, impact, philanthropies, development bank, and civil societies. He is a founding member of 2000 Watt Smart Cities Association in Switzerland, which demonstrates how it is possible to consume only as much energy as worldwide energy reserves permit, and which is justifiable in terms of the impact on the environment. So let's hear from him. Over to you, Kanakji.
Thank you, Indrani ji. Good evening to all. Let me just share my screen. Ma'am, can you see my screen?
Yes, Kanakji.
Good, great. Thanks. So good evening, everyone. The topic of my presentation today is the use of integrated tools for achieving sustainability in the built environment. So before I delve more into my presentation, the first thing which we need to understand is why we as a country or we as designers need to develop sustainable buildings. So the broader context to this thing is climate change, right? All of us understand that the climate change, the prime contributor are the greenhouse gases. And in the international commitments, we have already in line with the Paris Accord, which talks about limiting the temperature increase to 1.5 degrees Celsius compared to the pre-industrial level. And for this, like all the countries develop their nationally determined contribution where they pledge to reduce their energy or the carbon intensity. So these are like nationally determined contributions. India is also bound by the Sustainable Development Goals. And also there is another international treaty which looks at, which is called Kigali Amendment to Montreal Protocol, which talks about how we can use sustainable refrigerants in the cooling. So all these things are the commitments which the country follows in terms of committing to the carbon neutrality goal. And all, as Ashish ji already mentioned, that now we have been also committed to become carbon neutral by 2070. So that is one of the most recent and the important reasons why we look at decarbonization in the built environment. And many of the impact of this climate change is now quite visible, whether it is drought, floods, hurricanes, or even the urban heat island or the pollution. And all these are caused by the human activities, and one needs to understand them better and try to become more resilient towards it. Then we understand that climate change is important, and one of the major contributors for the climate change or the global warming is the energy consumption. And we understand that the building consumes about 33.1% of the total energy consumed in the country. And if you look at any buildings, whether it is commercial or residential, 70 to 75% of energy gets consumed in air conditioning and lighting of the building. So it is very important that we start giving more importance to the design. We understand that although the design phase can be from 6 months to 1 year, but we are going to construct something which is going to last for 50 to 75 years. And we are going to spend a lot of time indoors, where again, the main purpose of the building is to provide better thermal comfort, acoustic comfort, visual comfort, and air quality. So this is very much need. There is a very much need that although the things are becoming more faster and we get less time, as Dr. Varun has mentioned, for designing, but there are now tools available which can little bit accelerate the process, and that is where the whole discussion about integrated tool and BIM comes into picture. So when we look at how to do high performance building or low carbon building, as Ashiji mentioned, that we look at passive strategies. Passive strategies are the strategies which does not consume any electricity. In simpler term, one can think of it as insulate well, shade well, and ventilate well. The idea is that we need to be much more inclined towards harnessing the potential of climate around the site. And once we have put forward good passive strategies into the building, then we need to look at, like, to attain the thermal comfort and the air quality, what kind of active systems we need to put, whether it is related to artificial lighting and control, or related to, let's say, the air conditioning system in the building. Now I will just give a high level background about, like, how the presence of this integrated tool comes into being. Not very far off, like 10 years back, we have seen, like, a lot of architects were using, let's say, these arrows in their drawings to depict how the sun and wind moves. But this is quite intuitive in nature. In real life, we do not see this kind of a physics. So because of that, a lot of times we have seen that either the strategies which get implemented from the sustainability principles does not really lead to the final results, which Ashiji mentioned, that the performance is not achieved, but in the design intent, it is there. A lot of engineers would have seen something like this in the wind tunnel airflow analysis. Again, it is a quite a unique setup one needs to have to really understand the airflow around the building and inside the building using wind tunnel. I have also witnessed a case where, before creating, let's say, a ground plus 4 structure, the architect and the consultants wants to make 1:1 prototype of the building, where they try to put all the envelope strategies, cooling strategies, and lighting strategies, and run it for one whole seasonal cycle. And after that, they basically come to a conclusion that what they need to implement at a full-scale building. But what we have seen that all these methods, which I mentioned earlier, are either less accurate, and they are more time-consuming, and in many cases, they are also cost-intensive. We have seen, because of the intuitive design nature by the designers, to implement one strategy, they implement multiple layers of interventions, and that leads to the cost ineffectiveness of the overall building project. So all this can be now addressed by using the integrated design tools. And I am very happy to see that in the industry, now the integrated design process is quite well accepted, where, let's say, architects, engineers, client, contractors, everyone come together and basically together develop the performance standard for the building. So that is happening at the stakeholder level. But at the same time, we need to also deploy right tool at the right time of the building phase, whether it is design, construction, or operation. So whenever we look at basically the energy simulation or daylight simulation, we use particular software. Okay, what I mean by simulation here is we make a virtual 3-dimensional model of the building, and again checking various interventions, how they perform in that building before it gets built. So whenever we choose a tool to do simulation, the important point is, like, what kind of inputs that tool can take and how user-friendly that software is. The second part, which is again very important, is what kind of engine or simulation software used to do the thermal analysis, daylighting analysis, and finally, what kind of output it produces. So all these three things are very important, and that basically dictates, based on the time availability as well as the stage we are in the project, what design tool one needs to do it. Over the past 10 years, I would say we as the designers who support architects using these tools have started moving away from tool to toolkit kind of a solution where we can create a kind of a model which becomes a central model like in BIM, and then basically use different tools to find out how sustainably we can basically look at various interventions. So when we look at start doing the evaluation of the project, these tools allow us to understand how the sun moves around the site. I understand that most of you will say that we move around the sun, but in order to understand, let's say the shading patterns within the building, mutual shading, we basically do the sun path analysis where we try to see that different seasons, like how the sun moves around the building, and which spaces can be used during the winter times, which space can be used during the summertime. Then after understanding the sun path of a particular location, you also start looking at what are the kind of wind patterns at a macro site level. Again, trying to see whether the designs, urban design has been done in a manner so that it ventilates well and leading to reduced urban heat island in the space. We do some radiation analysis for looking at the massing of the project. And once we know that the project is well sited with the orientation and spatial configuration on the site, the second thing which we look at is like how various building components can harness, let's say, the natural elements of sun, air, or vegetation around the site. So we do a lot of parametric analysis where one by one we can change each material and try to see how we can reduce the load, reduce the energy consumption, and finally also seeing that whether we can also do renewable energy integration with the building. And the essence of doing this kind of an analysis is that you do it on a central model, which has the capability of interoperability with other softwares which designers use, or basically using a big platform itself and adding multiple plugins to do the analysis. Looking at the computational fluid dynamics capability, one can look at doing a site level wind flow analysis to understand how the ventilation effectiveness can be reached in the urban context. One can also look at various building level indoor CFD simulation to understand the temperature distribution, airflow, contaminant, diffusions. All those things can be analyzed now before the thing gets built in the state-of-the-art tools. Again, the important part here is what kind of output you are going to look at, what engine is the best suited engine, and whether the inputs provided to the tool can be put easily. These are some snapshots of the daylighting analysis. One can find out whether the windows area or the glazing properties are appropriate for enough daylight inside the building. Beyond daylighting, one can also perform artificial lighting analysis. And here we are trying to look at how we can harness better the daylight. We can select various lighting fixtures, and at the same time trying to look at also the uniform distribution of lighting within a zone. So again, this is a project in Delhi for United Nations. Now moving slightly away from design, now we look at something which is more like digitalization, and where we are mainly looking at operational efficiency. So now, like we have IoT, data analytics, which are getting quite popular because of cheaper cost of these IoT equipments, and also the acquisition and the analytics at the cloud has become now quite affordable. So one can basically collect various parameters at the building level, neighborhood level, or at the city level, and then basically take them to the cloud and try to do data analytics at the cloud and get various key performance indicators so that we can operate the building efficiently. One can get various dashboards, which can be at the desktop or the mobile level. And the data analytics using machine learning also helps us in doing predictive maintenance and controls. One of the things which Ashishji mentioned also was the digital twin. So in our context, we consider digital twin as something which basically get data from Internet of Things and do artificial intelligence or machine learning algorithms on top of it. What we have started doing as a novel thing at our office is we have also added the building energy simulation platform with this digital twin. And by doing this, what we were able to do is we not only look at the performance of the equipment, like an air conditioning equipment, but also see how the envelope responds to the dynamic interaction with the thermal performance of the building. And this is something which really helps the owners to operate their building rather than on a sense per parameter like temperature, air temperature. They can run the overall building on the key performance indicators or operative temperatures, which is actually the human being feels. So there is always a merit when you connect BIM with IoT or with the data analytics part. So with this, I come to an end to my presentation. Over to you, Randy.
Thank you so much, Kanakji, for sharing all the aspects of designing prospects. And I have with us Mr. Ali Hassan Khan. He's supposed to leave actually, and he has a question. So can we take his question, please?
Sure, definitely.
Okay, so I will read the question, ma'am.
Yeah, sure, please. Go ahead.
So I'm an energy analyst. I have never worked on BIM or any BIM software. However, I worked on Energy Plus, IES, Design Builder, and Equus. My question is, what are the crossroads for BIM and energy simulation? Or more specifically, how much percentage does energy contribute to the BIM on the whole? Okay, so I will give you a high-level answer and then I will request the other panelists to also respond. So where I see a kind of win-win between BIM and energy simulation is that now the BIM has the capability where you can run your, let's say, Energy Plus engine. You can make the model in the BIM platform, and Energy Plus can be added as a plugin to it. And now what the BIM also allows is something called visual programming, where you don't need to really understand the coding part of it. Through the visual programming blocks, one is able to really transform your analysis, whether it is thermal analysis, daylight or artificial lighting analysis. So I see a good overlap now, and most of the BIM platform now allow for this energy simulation either within the BIM platform itself, and some of the software also allow the exchange of BIM model to their platform, which Dr. Varun mentioned, GPXML5. So I see a good interoperability between the two platforms. Any other experts would like to take this question? Varunji, you take it.
I think you have answered it well, Kanak. Mr. Ali Hassan can let us know if something is missing in this. And when we say interpretability, like you have mentioned some softwares, IES, yes, there is an interpretability of data from one BIM software to another. Design Builder also has that. Equus doesn't have that.
Yeah.
So yeah, so there are some software which does not have the interpretability data. Like in HAP also, you can get the input from any other software, but you cannot take a HAP output to any other BIM software. So those are the limitations with few of the BIM softwares.
I hope
Also asking what software is it with E+ plugin?
Energy Plus is itself an engine. If I understand your question, that you want to understand which all BIM platform can connect to it, right? So Revit is able to connect it through Dynamo. So that is what I understand. I also know, let's say, Rhino Grasshopper, which is not essentially a BIM software, but it can also import GPXML file, and then an Azure Plus can be run on top of it. Good. Indrani ma'am, can you take
So
over?
can we move ahead?
Yes, ma'am.
Okay. Right, I'll share my screen again. Give me a moment, please. Yes, before we move to our next speaker, I would like to thank first of all to our annual sponsors. Those are Advanced Valves, UP Trigger, Airflow, ALP Aeroflex. But without the event sponsor, one cannot run the show. Sorry. And we are being in a society, we always seek or try to get a sponsor for our event. And luckily, we got our sponsor for today's webinar. They are Capricorn and Autodesk Platinum Partner. So we are wholeheartedly thankful to our Capricorn and Autodesk for sponsoring this webinar session, wonderful session with great speakers. And last but not the least, we have with us Mr. Tanveer, Mohammad Tanveer with us. He is a BIM specialist, MEP, Capricorn Technologies Private Limited. Tanveer Ahmed Khan is mechanical engineer and AMP, currently working in Capricorn as BIM specialist, MEP, and Autodesk certified professional. Having 4 years of diverse professional experience with a broad set of skills in the AEC industry on the BIM platform and helping various companies implementing BIM technology. He also has demonstrated history of working in the MEP sector with various organizations and has been responsible. A well-rounded, hands-on, innovative leader committed to learning new design journals and continuously improving skills and processes. An enthusiastic, resilient, adaptable, and flexible achiever with keen attention to detail, Tanveer Ahmed Khan has been responsible for project coordination and delivery using Autodesk Revit, Navisworks, Dynamo, and Autodesk Construction Cloud. He has hands-on experience on projects such as residential, commercial, industrial, and institutional projects like hospitals. His core expertise lies in the architecture and MEP domain. So over to you, Tanveerji. I'll stop share my screen.
Thank you, ma'am. Thank you for the introduction. I'll just share my screen. Please confirm once it is visible. Okay, ma'am, I have shared my screen.
Yes, it's visible. Perfect.
Thank you, ma'am. So, I'll be discussing about how cloud helps in achieving low carbon emission and seamless project delivery in the built environment. So actually, I've divided my presentation in 2 parts. So initially, so what are the objectives? So to spread awareness on how cloud technologies helps in lowering carbon emission, to simplify and manage data using cloud for multidisciplinary coordination to facilitate on-time project delivery. Okay, so the first part is how cloud technology helps in lowering carbon emission. So I have basically the cloud computing and its 4 aspects. So the first one is environmental aspects. So migration to cloud from on-premises data centers actually helps us to reduce your energy consumption, and eventually it will also helps in cut down your CO2 emissions. And then the second aspect is technological. A cloud data centers is actually a cluster of remote distributed computing resources available on demand through web services. So it cannot exist without the internet. So then the third aspect is social, and fourth one is financial. So social aspect is actually it is available online. Cloud services can make it possible for all societies to access technologies and knowledge that would help them achieve further growth. And financial cloud computing allows businesses to save on purchasing buildings and maintaining IT infrastructures on their premises, as well as on hiring IT experts. So I'll be more focusing on these first two aspects, environmental and technological. So there are different ways how clouds helps in reducing CO2 footprints. The first one is higher utilization rate. So company use many more servers actually than they actually need it. As a result, the in-house centers have extremely low utilization rate, using on average as a little as 15% of their capacity. Secondly, higher equipment refresh speed. Because of that, new technologies that are usually more energy efficient, a faster refresh time reduces electric power consumption in the long run. Then we have new methods to reduce energy consumption. Now, since cloud data centers generate a lot of heat, as much as of 40% of the power they consume goes into cooling their equipment. To tackle this problem, some cloud providers use sophisticated cooling equipment with higher energy efficiency rates. Then we have shift to renewable energy. All the major cloud service providers gradually moving to green energy sources, for example, solar energy, wind, geothermal, etc. Then the remote working. Last, people who work from home don't have to use transport for daily commuting, which translates into saving 3 million tons of CO2 emission a year. Additionally, by replacing air travels with video conferencing tools, you're also minimizing your carbon footprint. Then one of the case studies from the major cloud service provider, Microsoft Azure. So according to Microsoft report, Microsoft Cloud is between 20 to 93% more energy efficient than traditional enterprises data centers. Then the second, Amazon Web Services, it also claims that its cloud computing resources can accomplish the same task with the 88% lower carbon footprint than their traditional counterparts. Then last, the Google Cloud, it also states that its data centers are 2 times more efficient than a typical enterprise data centers. So the second part of this presentation is how cloud-based workflow helps in seamless project delivery. So one of the answer is common data environment. So what is a common data environment? CDE. So common data environment is a digital storehouse where all the data of the construction project is stacked. So in other words, common data environment is a digital hub where information comes together as a part of a typical building information modeling workflow. Also, the common data environment is a single source of information used to collect, manage documentation. So what are the challenges in the construction industries? So we have very razor thin margins, tight schedules, siloed information. Then we have labor shortage, distributed teams, and uncertainty. So that is why adopting CDE in construction industry is important. So increased collaboration, it helps to increase collaborations. Then since it's a CDE, it's a single source of truth connected to the 3D experience. Then we have improved data accuracy, standardization, and then digitization. So what are the attributes of a common data environment? It is very easy to use and it is accessible, anytime, anywhere we can access its data. It is integrated, well integrated, and then it is scalable like other data centers. If we talk about, we can buy as per our enterprises requirement at any time, we can scale it. Then we have a standardization as well, and then it is very secure. So what is the traditional workflow versus common data environment? As you can see here, so traditional workflow involves actually we use to different stakeholders actually used to communicate through emails, through WhatsApps and all. So they don't have any central location to explain. Then we have this common data environment. As you can see here, that it helps different stakeholders are actually fetching their data from a common platform, which is a cloud platform. So what are the features of common data environment? So these three major features: document management, design collaboration, and model coordination. So the document management helps in, what are the key features of document management as well? If you talk about, so it helps in document control. We can control the rights of the document, who can view these files, who can share it, who can download. So we can control the rights at each folder. Then we have 2D and 3D supports as well. So without any softwares, we can directly see our models on the cloud, and we can see the 2D sheets as well. Then there we can create issues as well. Let's suppose we are exploring a model on cloud. So on that time, we can create an issue, and then we can assign it to someone who is responsible for that. Then we can create markups either for ourselves, for it can be for other peoples as well. Then we have this embedded data. Since all the data we have input through our design authoring tools, so all of these data are on the cloud as well. Then we have this version control. Since a lot of revisions happens in drawings, so we can have easily record of that, and so cloud helps in directly, it can accordingly organize it. Then we have this create transmittals, so since we are using clouds, we don't have to take printouts and all. We can directly share our transmittals through cloud. This will also helps in reducing taking printouts and all, so eventually helps in lowering carbon emissions as well here. Then we have this approval workflow, so that let's suppose from work in progress folder, so we have to share it to other stakeholders. So we have a internal team approval workflow, which will help to share files with other teams as well. So this is the customized folder structure. We can have on cloud a customized folder structure, at each stages of design, from concept to design development, then tender, then GFC and all. So within each stages, we have different folders like work in progress, depending upon different teams is work in progress. Then we have shared folder. So each team will have two folders actually, work in progress and a shared folder. So then the other teams can consume it from their team's space as well. So this is the video. I'll just share the sound.
That they are working with the latest information. No matter what they do or where they work, it would mean less rework, lower costs, and improved schedule timing.
So let's see what is document management in common data environment.
Ability for every team member to trust their software. From design through construction. A common data environment shared by design, quantification, coordination, project management, and field collaboration keeps all project data in one place. Native integrations with design software gets information published fast and in the desired format, meaning no critical project info is lost in the gap between incompatible solutions. You can keep the right information in the right hands with powerful document and version control. Customized folder structures and comprehensive permissioning keeps information organized. And advanced search makes it easy to find what you need in the office or on the job site. More advanced control is delivered through document review processes, making sure you only make information available when it is ready. And transmittals help you keep track of who has received what and when. Add in powerful markup tools and the ability to track and collaborate on issues across the lifecycle, and you've got real collaboration and coordination. One-click access to drawings, models, and even Microsoft Office files brings the power of collaboration to the whole team. Access to all data, simple viewing and collaboration tools, all without leaving the platform.
Okay, so collaboration and coordination through CDE. So we have talked about document management. Now we are talking about collaboration, how we can collaborate and coordinate on cloud itself. So in cloud, we have Revit Cloud Work Sharing, which means that from we can have a central file through which multiple people can work on the same model at the same time. Then we have the multi-team support, document management. It also include Then we have model coordination. Model coordination is actually, we can directly take out the clash reports. We can do the clash detection on cloud itself, like Varun has shared on different softwares. So the same thing, the same process can be performed on cloud as well. So who can collaborate and who can coordinate? So basically collaboration means intra-team. It is a process of working on the same project at the same time by the same discipline. And coordination means inter-team, different disciplines such as structure, architecture, and MEP teams can also come into play, so that they can coordinate with each other on cloud. So this is actually a diagram which is of level of trust with different stakeholders or different teams, we can have. So level 1, it is the highest level of trust. Then we have this level 2, which is the mid level of trust. Then we have this level 3, which is the low level of trust, So since, let's suppose one of the, so we'll see this in next slide actually. So this is, we have project teams, how communicates design updates through each other using design collaboration. Other teams get notified through timeline that a new package has been shared. So this is the model coordination. How we can perform clash detection with different models. It actually automatically take out the clash reports with different disciplines. As you can see here, this is taking clashes, and you can add different uh, different models with whom you want to take out the clashes. So for example, here you can see the structure file, and then you can also whether you want to share it, you can share it through your package, so that other discipline can also, they can consume and they can run the clashes. So this is the clash report, as you can see. So different, number of clashes, 162 between structure and other disciplines. So this is the clash report. And you can also, create a issue here directly. You can see at any clashes, it's a not whether it's an issue or not. If it is an issue, you can directly create an issue here, and then it can assign it to someone, and then you can so it will, it will share an email also to one we have assigned this issue, who will be responsible to solve this issue. So creating issue, this is how you can title it, then you can assign here, and then you can what the type of clash it is, and you can set the due date and all. So who will be responsible for it. So this is the so thank you, and this is the end of the presentation from my end, and I'll hand over to Indrani ma'am. Indrani ma'am, over to you.
Thank you so much, Tanvir, for such a nice presentation.
Thank you, ma'am. So I'll just stop my screen.
Now we will take the questions.
Yes, I think we can take the questions.
Should I read it out?
I
Or
think
you are going to take?
yes, I'm going to take, ma'am. I think initially all the questions have been taken. So one of the question from Ahmed Mustafa, what's the software used in 4D animation simulation? I think it's question for Ritesh sir. So he was showing some 4D simulation there.
Yeah, so Mr. Ahmed, so there are quite, I'll say, substantial number of softwares available in the market. So as of now, this particular video that I prepared, so Shweta just wanted to ask that we can name the software.
Yeah, in question answer.
Yeah, sure.
please tell
In
me.
question answer, yes.
Okay. So Mr. Ahmed, the Bexel Manager has been used for this animation.
Okay, thank you, sir. And the other question is from Sham Bhosle. One question to Ritesh sir. Again, this is to Ritesh sir. What will be cost for BIM software for HVAC industry? How this steps-wise procedure, like you had shown for construction, will be applicable?
Yeah, Mr. Sham. So I think the second part has been answered by Mr. Tanwar in his presentation, that ultimately all the verticals can come and collaborate only if the BIM model is there. as far as you are saying that how it will be helpful in the construction. So then if the model is there, then only the clashes could be done. And moreover, when I say that we can do the 4D, 5D tracking, billing processes, all those can be possible only if you have the schedule processes. If the MSP schedule is not available for that particular, let's say, vertical, then you cannot prepare the schedule actually. And as far as the BIM cost is concerned, so it is different for different verticals, I'll say. And it is not a software. BIM is not a software, it's a technology. It's a combination of software. So you can use Revit also, you can use ACC also, as he said, for collaboration. So under that, design collaborate comes into play. So it's a combination of software when you come to a BIM model. I hope that answers the question.
Thank you, sir. Thank you for the elaborated answer. I think we can move to our next question. Hi all. So this is my question is, it is advised to have a single point of contact for complete coordination with inputs from all parties, or to share the responsibility of coordination among all parties. So like Ritesh sir already mentioned that we have design collaboration through which we can coordinate with different stakeholders and different teams through cloud. Right, sir? Ritesh sir, anything else you
Yeah.
want to add? Yes.
Yes, absolutely. So just to add to it, so it is not a single point of contact, I'll say. So when you're doing a design collaboration, so as Tanveer was showing, so you can always share your model as a structure consultant, you share your model with the architect. Then architect
Right.
sees the model, see the changes and consumes it.
Right. Sir.
Similarly, the architect shares the model with the MEP. Similarly, the MEP person also sees the model and then consumes it. So every consultant is responsible for his part.
Thank you, sir. Thank you so much. Then we can move to the next question. I think who is responsible party to control versions of design in common data environment? So version control, actually, I think it is not controlled by any party. This is actually being updated by the software itself. The moment you try to update a new file, it was always termed as V3, V4, and then you can compare those versions on cloud as well. Right, sir? So anything you want to add? Any other speakers?
Yeah, Tanveer, I think you rightly said, so it is controlled by the software itself. And the only thing I think Tanveer also mentioned in the presentation that it is about the data which has been shared with you as a transmittal or as a review. So you consider only that data as the updated data. Unless until you have not received any other version, so the last received version remains as the updated version.
Right, sir. Right, right. Right, sir. So thank you, sir. I think we have covered all the questions. And so I'll hand over to Indrani ma'am. Indrani ma'am, over to you.
Thank you so much. Thank you, Ritesh ji, and thank you, Nazir ji, sorry, Tanveer ji, for taking up the questions. I would like to
Thank you.
invite Kanagraj Ganeshan ji, our president, to give vote of thanks.
Thank you everyone for being towards the end of this small webinar. I would like to thank Capricorn and Autodesk for supporting or sponsoring this useful session on low carbon sustainable technologies use. And from the AIC side, we have been doing a lot of these programs which are connected to students as well as young professionals looking at various tool usage. So we foresee that all of you can also become part of those events. At the same time, like the big thanks to Capricorn for providing the sponsorship so that we are able to organize this program. And also thanks to Ashish Rakheda ji, Ritesh ji, Tanvi, and Dr. Varun, and especially Shweta for coordinating the whole program for us. And we look forward for more fruitful association in the coming year as well as the days to come. Thank you.
would you like to say something?
Shweta?
Yeah. Oh, yeah. Hi, everyone. Thank you so much for coming together. It was a pleasure meeting all the speakers, connecting with them and listening to their thoughts. And Capricorn will keep supporting, Azure in their endeavors. That's it from my side.
Thank you so much, Shweta. Thank you, Ritesh ji. Thank you, Kanak ji. Thank you, Shweta again, and Tanvir ji. Varun ji has left. Thanks to Varun sir and Ashish Rakheja ji. Thanks a lot, and looking forward for many more. Thank you. Have a nice time.
Thank you.
Thanks to
Thank
all the
thank you,
attendees,
ma'am.
of course, not
Thank
to
you.
forget the attendees.
Yeah,
Thanks to
sure.
all the
Thank you, everyone.
attendees.
Thank you, everyone.
Thank you. Thank you all.
Okay, have a nice time.